Hello, my name is Dr. Scott Gerard, and I work at Knowledge Reactor. I would like to re-record a presentation I did a few weeks ago at AI Now, hosted by Karen McCann. When I did the presentation, then there was a lot of great discussion in the room, and unfortunately, I can't reproduce that. But there were a lot of requests for me giving another recording of it, so people who didn't attend can actually see the presentation. So that's what I'm doing today. And today what I want to talk about is ChatGPT and some of its implications. The agenda I'm going to go over is, what is ChatGPT? Kind of how does it work? Some of the attributes of ChatGPT that I think are worth investigating deeper, and then looking at some of the implications of the technology. The 9 people here on the top is just a small set of some of the AI visionaries who have offered their opinions on what ChatGPT and some of these large language models are all about and the implications of them. Some of them are deeply worried about this technology. Some of them are not so deeply worried. All I can say is these guys are a lot smarter than I am. I haven't detected a consensus among them yet. So mostly what you're going to get in this presentation is just really my opinions, but it's a very fascinating area and a lot of drama and things going on right now in regard to that. I think the crux of this whole issue is a quote that I've always liked by Melvin Kranzberg. Technology is neither good nor bad, and the technology in itself I don't think is good or is bad, but when humans get involved, it's not neutral. And humans are definitely getting involved with this technology. And I think what is certainly true is that large language models will be used for good. There is good that's going to come from this, but they will also be used for bad. And we need to figure out how to begin to control some of the undesirable effects of this. The first thing I want to do is just kind of describe, a couple of major areas of artificial intelligence. One of them is discriminative models. This is really, they use a conditional probability distribution for those of you who care. But the idea is that I'm going to give you like a picture and I want you to classify it as a cat or a dog. So this is a very simple output. I'm getting, one cat or one dog coming out of this. A lot of information went in, but not so much came out. Those are discriminative models, and they've been very useful for the time being. But for some of the things we're seeing now, they're generative models. The probability distribution they have is different than the discriminative models. Here we're talking about trying to learn the full joint distribution. But the idea is that I give you a bunch of text, and I give it the algorithm a bunch of text, and out comes a bunch of other text, a much more complicated, complex output than just cat or dog. If I'm working with images, an image in and an image out, or video in and video out. It's just a much more complex model. And these are generative models. Now, what we're going to talk about today, what I'm going to talk about is focused mostly on GPT 3.5. That's the base model, the foundational model. And then ChatGPT was fine-tuned on top of that. It's a somewhat different model, but it's certainly based on GPT 3.5. But there are other models as well. There are many, many other models. I've listed the ones here from Google, Lambda, and Bard. But from the image point of view, there's a bunch of things out there. Midjourney, Stable Diffusion, DALL-E 2, a bunch of models out there that do this. I'm just going to focus on one of them. I don't think it's going to be radically different for some of the other models, but just to kind of keep things simple, we're just going to focus on ChatGPT. Now, the one thing I want to say is we're talking about generative models, and the G in generative is the G in GPT, okay? So that's where the G comes from. We're building these generative models. So how does ChatGPT work? Well, I'm going to lie to you on how it works here. And the reason I'm going to lie to you is pretty well summarized by George Box. All models are wrong, but some are useful. All of the models that I'm going to describe to you are not actually exactly how ChatGPT works, but I think they will be useful to help you kind of understand what's going on. This first model is the one that I would recommend, that if you only remember one, this is the one to remember. So what we're going to do here in this first model is I'm going to take like 50,000 words from the English language, and I'm going to build a graph out of it. And each node of the graph contains one word. And I've listed some of the words here. The black lines over here are just supposed to suggest other words that I don't really care about here. But there's 50,000 of these, and that's the nodes of this graph. Now, what I'm going to do is I'm going to train this model. So if I take this first sentence, Luke is a Star Wars Jedi, I'm going to get down, and at one point I'm going to say, well, I have star followed by the word wars. So I'm going to go to the node for star and the node for wars, and I'm going to add an edge between those two over here, and I'm going to set the weight of that edge to be 1. And then I'm going to say, well, the next pair is wars to Jedi, and I'm going to add an edge there, and I'm also going to assign the weight of that edge to be 1. Now I come down to this second sentence in my training set, and I see Star Wars again. So I've already got an edge from Star to Wars with weight 1, but now I've got another example of that in my training set, so I'm going to bump the weight to 2. I've got Wars Trilogy, so I'm going to add an edge from Wars to Trilogy, and since it didn't exist, I'm going to set its weight to 1. And I'm just going to continue to move down through the training set, building and bumping, or building edges and adding and bumping their weights. Now, in the ChatGPT model, there is a pre-training phase and a fine-tuning training stage. So there's two kind of different types of training going on here. In this model, I only have one, but the most expensive one is the pre-training, the first level of training. That's the one that takes the huge amount of computing process. And so pre-training is the P in GPT. So we have generative and we have pre-trained models. So I'm now done with the training here. So how am I going to generate text from that? Well, I'm going to start by generating text by randomly following the weighted edges in the graph. So let's assume that I'm given Luke is a star. This is kind of the prompt that you would start with. In ChatGPT, the prompt is going to be much, much longer than this, but in this model, that's the closest analogy to what it is. So I've got Luke as a star, so I'm going to end up at the word, the node for star, and I'm going to say, what is the next word that follows star? Well, I'm going to look at all the edges out of that, and I can see that star to wars is a really heavily weighted edge, so there's a lot of chance that I'm going to generate that. But there's also a chance that I might go to star player, follow this edge here. It's not very likely, but it could happen. But anyway, so I'm going to randomly pick one of these edges, and let's just say I pick star or pick wars. So now I've generated one word, and now my phrase is Luke is a star wars. Well, now I'm going to go through the whole process again. I'm now going to generate the word after wars. And if I look through that, I've got some options up here, but I'm going to randomly pick one. And let's just say I pick the word Jedi. So now I'm up to Luke is a Star Wars Jedi. I don't know what comes next, but I'm going to continue to follow this through. So I'm just randomly picking words based on their weights. But this is where you might get where you'll sometimes hear the term GPT is a statistical parrot. It's just regurgitating what it learned from its training set, nothing more. And it's statistical because it's randomly choosing these edges to follow. So that's what's kind of going on here. And like I said, if this is the only model that you remember, this is the one to remember, okay? So how well does this perform? Well, when I first started my job, we had a program at work called William, and William was trained on the text from William Shakespeare's plays and other things. And it would generate text according to this kind of a model. And when you would look at, 3 words, 4 words, 5 words, it really looked like it came from William Shakespeare. Lots of these and thous and henceforth and that kind of stuff. And it looked pretty good. But if you got a whole sentence or a whole paragraph, it just kind of wandered around and it never really ever said anything. And so it wasn't really very useful. And the reason that's the case is that it doesn't have enough memory of where it's been. It doesn't remember the first part of the sentence when it gets to the last part of the sentence. And so they're completely disconnected. And that's what this William program would do. And that's the problem. We don't have enough memory. We don't have enough context about what's going on to do this. So how can we fix that? Well, let's go to version 2 of this model. The previous model, the words at the nodes of the graph were unigrams. Each node had a single word in it. What I'm going to do now is I'm going to use bigrams. So I'm going to build a different graph. This time, the nodes of the graph have word pairs. So World Wars, Star Trek, those are all nodes of this new graph now. But I'm going to build the edges just like I did before. And so we can have Star Wars goes to Wars Jedi. And now I've got, when I go to build this edge, I not only have the word wars here, but I also have star. I have a little bit more of the previous context, a little bit more memory of how I got here so that I can generate more interesting text. And if you look at it, World War Jedi doesn't really make much sense. It was possible to generate that in the unigram model, but in this particular bigram model, there's no longer an edge between them, so that would no longer be generated. So the output would be a little bit more focused. I've added a little bit more context, a little bit more memory, and I should get a little bit better result. So I went from unigrams to bigrams. I could go from bigrams to trigrams to 4 grams to 5 grams to whatever. The problem is the graphs now, when you get up that, are just becoming immense, and that just doesn't really become workable anymore. So the problem is context and memory. How do I deal with that, but not with these n-gram models? And the answer is with a transformer architecture. The sentence here, there's 2 sentences. One is the animal didn't cross the street because it was too tired. And this one is the animal didn't cross the street because it was too wide. Well, the it here refers to different things. The first part of it all kind of makes sense, but how do we understand what it refers to? In the first case, it refers to animal. The transformer architecture figures out that animal is the most likely referent here because an animal can be too tired, but an animal can't be too wide. That isn't why the animal didn't cross the road. Maybe it could be, but in this case, it's more likely that it here refers to street. So the it is referring to generate the word after it. It has more context, but the right kind of context. And it's a lot more compact than just using these n-gram models. And the transformer is the key piece of what makes ChatGPT work. And that is the T in GPT. So we have generative, we have pre-trained, and we have transformers. That's where GPT comes from. Now, I've also lied to you in another way. I was doing these models as if the words were discrete, that there was a node and each node had a word in it. And the only words that I had were the nodes that were in the graph. And if it wasn't in the graph, it didn't exist. But what we're going to do now is move from discrete words to continuous embeddings. This is a little bit different picture of a graph. This is various kinds of novels. And you can see that they've been grouped. So like nonfiction, all the nonfiction ones kind of end up here. That's kind of cool, right? Encyclopedia Britannica is one of them, and it's up in the middle of this nonfiction stuff. 1984 is a novel. It's kind of in with a lot of these orange ones, but there's also some purple stuff in here, the historical novels. So what's happened is now 1984 as a single would have been a node in the previous models. Now it's represented by 2 coordinates. It's got an X coordinate here, and it's got a Y coordinate here. So I no longer have discrete things. I have continuous embeddings. But the nice thing is they group together in this space pretty well. Like I said, the nonfictions are up here. The novels are in here. That's an interesting part of this embedding, and that's one of the ways we're going to do it. Now, what I'm showing here is an embedding space of 2 dimensions. In reality, these are much larger spaces. There's like 300 dimensions, 500, 1,000. I think ChatGPT has been reported to be 1,536 dimensions. These are just ginormous spaces. That's really hard to describe how large these spaces are. But the words have now been embedded into this very large space. And that gives us a lot of capabilities. The grouping is here is one thing, but it's also giving us the ability to kind of do, there's other things represented in here as well. There's a 2013 paper by Mikolov that said, man is to woman as king is to what? Well, it turns out that the vector between man and woman, if I take that vector and add it to king, I'm going to get a point in this embedding space very close to the word queen. So I can say man is to woman as king is to queen, because the vectors of this particular difference are pretty much the same. Here's one on verb tense. Walking is to walked as swimming is to what? As swimming is to swam. These embeddings help us do this kind of thing. Here's the countries and capitals. The capital of Canada is Ottawa. The capital of Spain is Madrid. The capital of Italy is Rome. These vectors between the country and the capital are very similar to each other. And that's another element of this whole embedding space that makes them very valuable. So we've moved from, discrete unigram models through transformers all the way up to these embeddings. The transformers are still very much involved. To go much deeper and get a more accurate picture of how ChatGPT works is beyond what I'm gonna do here today. But I'm hoping that version 1 will help give you some idea of what's really happening. So let's look at the attributes of ChatGPT. The first one is language. I think ChatGPT generates some of the best, most fluent English I've ever seen from AI. And so on that grounds, I give it a check. It's great at generating language. What about creativity? Well, if you ask ChatGPT, give me 10 ideas for a particular topic, and you say, hey, this is some pretty great ideas, I'm going to pick these and go ahead with them. I think ChatGPT is great at doing this kind of creativity. So for marketing and sales kind of stuff, I think it's a great application as long as you are looking at what's coming out of it. But that takes us into the hallucinations and the veracity. It often generates really good answers. And for that, it deserves a check mark. I mean, it's great. It's good. But there are also cases where it's just blatantly wrong. The one that I like the best is someone asked it, when was the second time the Sahara Desert was carried across the Golden Gate Bridge? Well, we look at that and go, that's just a ridiculous question. There's no answer to that. ChatGPT came up with a date. I don't remember what the date was. It isn't important. We look at that as humans and go, that's just stupid. That's just ridiculous. And we drop it and don't consider it any further. And that's good. But the concern I have is, what about those answers that are just subtly wrong? They are wrong. They're equally wrong to the wrong blatant answers, but they're not so blatant and we don't understand that it is wrong and we might go ahead and use it. That's the real concern. And that's why I kind of give this an X on this. The hallucinations are a problem and we need to get them addressed somehow. One of the phrases I heard, I forget who this was from, but I remember it very clearly. Large language models are language models. They are not truth models. So it's great at generating language, but it's still not that great at generating truth. It does a great job a lot of times, but you just don't know when it's fallen off the wagon and when it's hallucinating. So just keep that in mind. And as a particular case for this, let's look at the Avianca Airlines court case. Roberto Mata was suing Avianca Airlines and said he was injured when a metal serving cart struck his knee. Okay, it's a lawsuit. He hired Stephen Schwartz from this firm, and then Stephen went out and used ChatGPT to create a legal brief. And in that legal brief, ChatGPT generated more than a half a dozen relevant court decisions. Stephen submits this to the court. And that's great until neither the judge nor the opposing counsel could find any of these citations, any of these non-existing citations. ChatGPT made citations that looked good, but they just didn't happen to exist. That was a big problem. Um, Schwartz may be subject to disbarment because of this, because he so misled the court. And I've talked to some people that have said if the judge is mad enough and upset enough, he could find Schwartz in contempt of court and give him jail time. I don't know what the answers are. They've had some hearings. I don't know. I haven't seen the final result of those hearings, but Schwartz is in deep yogurt at this point over his just blind use of ChatGPT. And to just kind of put a different face on it, maybe it could be that the purpose of Schwartz's life is only to serve as a warning to others. Maybe that's the case. I don't know. But I'm hoping you will be very cautious about this, and no one will accuse you of your purpose in life being to serve as a warning to others. I think humans need to be in control of this whole thing. You are responsible for your use of ChatGPT's output, and you are accountable for it, in my opinion. So responsible is you had a task to perform, you performed the task, you were responsible for performing the task, you did it. But if it goes south, when people come and are angry about it and it goes badly, it's your throat they're going to choke because you were the one accountable for it. So you need to assume that you're accountable for your use of ChatGPT and consider what it's giving you and making sure that it's correct. The last topic here is values. Oftentimes people refer to it as bias, but values are good and values can be bad. Some good values, some good bias are these inductive biases. And an inductive bias is an assumption or preconception that a model or algorithm makes about the underlying distribution of data. If you're doing Bayesian analysis, by the way, for those who know what that is, this is the prior. You have to assume some prior. You're giving an inductive bias by picking the prior that you're putting in there. So for example, if you're saying, I want to use a linear regression model to look at this data, then you will have inductively biased the analysis to look only for linear relationships. If that's what the data has in it, then you're gonna find it just nicely, and that's great. But if it doesn't, it's not going to work. So the inductive bias is important, and it will help you find answers that you may not have the resources to find otherwise. And for those of you who know about the no free lunch theorem, you really need these inductive biases to get around that. So biases can be good, no question, but they can also be bad. And when most people talk about bias, they're talking about these bad biases. So we don't want to be biased against someone because of their sex or their race or their age or their disabilities or their religious beliefs or a long list of other things. And when most people talk about biases, they're thinking about the bad biases, but don't forget that there are these good biases as well. So some people have argued that ChatGPT is progressive or woke, and there is some evidence to suggest that. But the real question is, it's got to have some values, it's got to have some biases to do anything at all. But whose values are they? And what values are in there? How do we even describe the values that are in there? Even if we use the term woke or progressive, that's too general and too vague of a term to really get down to some of the more detailed values that we really need to understand what's in there. And I'm not sure how to do that. I think it's a really interesting question, and I'm not sure which way to really approach that problem. Another interesting part of this question is the is versus ought distinction. Hypothetically, let's say I look in the back of the room and there's a nurse back there. And so what pops up into your mind? Is that nurse a man or is that nurse a woman? What is the case is that currently 83% of nurses are women. So if a woman popped into your mind, that is the case right now. What if I say a soldier just walked in after the nurse? What pops into your mind now? Is that soldier a man or a woman? What is the case is that 73% of soldiers are men. Maybe you don't like these numbers. Maybe you think it ought to be something else. Maybe it ought to be the case that nurses are 50-50. Or maybe you think it ought to be the case that soldiers are 100% or 99% men. If it ought to be something else, whose ought is it? Whose values are we following when we think it ought to be something different? It's okay in some cases to bend these things, because some of these is scenarios, these is cases, may be based on prior biases that we don't want to continue. But then what ought it to be? And I just think that's a very interesting case to look into. Some people say it ought to be something else that we're probably not all going to agree on what it ought to be. So now let's look at some of the implications of this whole large language model stuff. On the left here, I have a spectrum. At the very bottom, we have early AI technologies. And these, I'm kind of thinking generically that these are technologies from the 1950s or 1960s, something very early on. And at the top, we have AGI, Artificial General Intelligence. This is human level intelligence, an AI that is as smart as a human is. And where does ChatGPT fall on that scale? Well, first of all, I just want to point out that there have been numerous expectations of what AI can do, that what we can build in the near future. In fact, John von Neumann, the guy who defined the von Neumann architecture that all of our computers basically are built on these days, that John von Neumann, a very brilliant guy, he thought we would have essentially AGI. He didn't use those terms. He thought we had human level intelligence by 1949. That's 7 years before the term artificial intelligence was even coined. So he was smart, but he was also desperately wrong. There have been a number of AI winters since then. The 1960s had overwhelmingly exaggerated claims for what could happen. They thought they were real, but the people that were in the field just didn't understand how difficult AGI was really going to be, how difficult it was to handle all of the cases that had to be handled. So there was a lot of AI winners. This overhyped, over expectation led to people being discouraged, and it led to dry up of funding from the national sources. And so that's what the AI winners are. And we've had multiple AI winners because of these overinflated expectations. But it keeps coming back. AI keeps making progress, and that's good. To get to where we are today, there's been a lot of great advances. Neural networks, the backpropagation algorithm, dropouts, GPUs, transformers, all kinds of things have helped us to get to where we are today that we didn't know back in the 60s and the 70s and the 80s. So we've made a lot of advance, and we've done a lot of really amazing things, even though we've had these AI winters. So what about ChatGPT itself? There's a term called emergence. And the question is, how do these large language models work? Well, I can explain to you at the level of the neurons and the level of the layers and the backpropagation, how all this stuff flows through and how things happen. But there's a lot of things that I can't explain about how they work. And nobody else in the industry knows how to explain them either. The one that I've always thought of was kind of a killer was, where is the world knowledge encoded in these models? I want to be able to point to the architecture and say, yep, there's the world knowledge right there. See, that's how it's encoded. Maybe I don't understand it perfectly well, but that's where it's at. And I can say, we have world knowledge. I can't do that for these large language models. So, you would say, well, they don't have world knowledge. Well, they kind of do. How is world knowledge encoded? Is it encoded in the language itself? Does English contain world knowledge? I've never thought of it that way, but ChatGPT is coming up with a lot of knowledge, and I don't know exactly how it's getting there. It's emerging out of this large network of weights. What about human creativity? Did Albert Einstein just put a bunch of things together that were statistically close to each other and come up with his theory of special and general relativity? I don't know. What about some of the other massive breakthroughs in our understanding of the world? Maybe there's something going on there. It's creative to a certain degree. Is it creative to a human level? I don't know. And we've talked about the values. Where are the values encoded? How are they encoded? What values are in there? I can't explain that right now. There's a number of things that just emerge out of these large models that are still at this point unexplainable. And we need to get a better idea of how that happens so we know how to control them. So you can see from this chart on the left that I don't think large language models are artificial general intelligence, and I'm very convinced of that fact. and many other people are. There's a few people that think it's close. But how far away are we? I heard an interesting quote. I don't remember where I heard it, but the guy said that we are 5 Einsteins away from AGI. So besides the neural networks and the backprop and the dropout and the GPUs and the transformers, there's 5 more kind of fundamental things that we're going to need to get to AGI. I don't know if 5 is the right answer or not, but I think there's a number of steps that we need before we're going to get there. But these advances are coming very quickly. I don't know how many years it will be before we get there, but I think there's a number of interesting, important technical advances that need to happen first. So now let's switch topics and talk about existential risk. What is existential risk? I think everybody would agree that if no humans are left alive, that's an existential risk for humanity. The other one that I heard that I didn't think of right away, which I think is also quite interesting, and I would classify it as an existential risk, is what if we have no human agency left? That is, humans are now the slaves or the pets of their robots. That's a different kind of existential risk, but I would put it in that kind of a category. It's that serious. There are other technologies that we've developed, particularly in the last 100 years or so. Nuclear energy certainly can pose existential risks to humanity. Synthetic biology and gene editing, I would put in that category too. But artificial intelligence also can potentially pose existential risks to humanity. I'm not concerned particularly about near-term existential risks, but I am concerned about misinformation and disinformation. And I would just remind everybody that the elections of 2024 are coming, and they're coming very fast. And ChatGPT can be used to introduce a whole lot of very believable misinformation into the mix. And that's a concern for our democracy, at least. So are there problems? Certainly there are problems. How do we address those problems? Well, a lot of people go, we need some regulation. We need to get the lawyers involved and shut some of this stuff down. I'm concerned about that. Earlier in the year, there were like 1,300 scientists, many of them luminaries of the AI field, and they proposed a 6-month moratorium. Let's just stop work on these large language models and spend 6 months trying to figure out how to control them. I never really thought that was going to work. I like the intent that we need to do more on the controls part of this, but I never thought that a moratorium itself would work. Russia certainly wasn't going to stop working on their large language models. China certainly wasn't going to stop working on theirs. So all that was going to do was put us behind by 6 months. So I think it's a great intent, but I didn't think it was ever actually quite the right idea. But if you want to listen some more, to dive in some more about these legal aspects of it, Sam Altman, Gary Marcus, and Christina Montgomery testified before the Senate. I don't know, it was about a month or so ago. That was very interesting. They suggested a few things that could maybe be part of the controls structure, but nothing definitive, nothing kind of expansive, just some general initial ideas. The EU, European Union, has this AI Act that they're working on. They expect to finalize it by the end of this year and expect it to go into legal effect in 2025. I think there's a number of interesting ideas in that. It won't be the end all of what we need, but we got to start somewhere. The White House last year came out with this non-binding blueprint for AI Bill of Rights. I'll show you that in a second. And Senator Schumer has also come up with his safe guidelines, and I'll show you those as well. Here's the blueprint for the AI Bill of Rights. Now, this is non-binding, but they have 5 principles, and this is a summary of it. Each of these has like a paragraph in addition behind it that I'm not showing here. Some of them have a couple of paragraphs, but that's the kind of amount of volume that they're describing here. But things like safe and effective systems. Well, that seems like a really good idea, right? Algorithmic discrimination, protections from that. What about data privacy? Well, we should have that, right? There's a bunch of things in here, not really anything that you would disagree with a lot, I don't think, but it doesn't really, drive a stake through the real control issues that we have here. One of the interesting things they did was they framed AI regulations as a civil rights issue. So freedom from something, right? I thought that was a very interesting tact on it. It's not really a technical approach, but it is a legal approach. But then some other people, this Daniel Castro said, well, the Fourth Amendment already guarantees unreasonable intrusion from the government. Maybe that's the only law we need. We need to flesh out kind of how that applies to AI, but maybe that's the only legal things we need, and it's already enforced. It has been for hundreds of years. So not quite sure where this is going, but that's one approach to it. Here's Schumer's safe guidelines, and the SAFE correspond to the first 4 words here: security, accountability, foundations, and explainability. Innovation didn't fit the word safe, but it's the 5th thing. I will tell you that these are his guidelines. This is the total sum of his guidelines. So there's not a lot of material here either, but it's useful. Which really kind of brings us to what is the spectrum of control that we want to exert here. On one end of the spectrum are really just kind of technical requirements, right? We need specific language, and technologists are usually going to be pretty specific. The language will be pretty narrow. The documents will be longer because they have to describe all the terms that they're using and that sort of stuff. That's the kind of thing that you would expect on this technical end of the spectrum. And some examples are the precision needs to be greater than X%, the recall needs to be greater than X%, whatever your metrics are, but they're going to be much more technical, much more specific about what really needs to happen. On the other side of the spectrum, we really have the legal part of it. And these legal requirements, the language there is usually much more generic. The language is broader and fuzzier, and the documents are shorter. We saw that in Schumer's guidelines and the AI Bill of Rights. But they have different principles in there, like the right to be forgotten or no unsafe systems. But there's this spectrum of things. I think they both kind of have problems. They both have benefits. But I've been kind of wondering, maybe is there something in the middle that's kind of midway between them that tries to get the best of both worlds and ignore and get rid of the worst of both worlds? I don't know what that is, but I think that's an interesting place to kind of focus and begin to think through. As an example, let's assume, hypothetically, that no one has ever murdered anybody before until just recently. So if murder has come up, what would the technologists do? Well, they would say, hey, we think pointy sticks are dangerous and you shouldn't throw rocks at people. And you need to be careful with X, and people can be hurt by Y. It's a much more technical, specific, narrow kind of a language. But the legal approach to this would be something very simple, like thou shalt not kill, right? And that's really interesting. But let's look at the question, did Alice murder Bob? Well, Alice has to be a person for Alice to murder Bob. Tornadoes don't murder people. And Bob also has to be a person. Alice can't murder her plants. The other thing is Alice had to perform some action X. We don't know what X is. It's not specified, but Alice performed some action X on Bob, and X was the cause of Bob dying. This kind of a definition is including the right concepts and excluding the wrong concepts. So like the action X here, right? We don't really need to specify what X is, but if X caused Bob to die, then that's part of Alice murdering Bob. So we need to understand that. And the point I was originally trying to make with this slide is that murder has a much better defined set of concepts that are the right concepts and not the wrong concepts. And we've understood what some of those concepts are. In terms of ChatGPT, I don't think we really understand what those concepts are that we want to get a hold of. We're going to end up with, pointy sticks or dangerous kind of a thing. And so I was going to hold this up as a great example of how, with time, we've gotten the right concepts and we now understand what murder really is, and that's a good thing. Problem is, after thinking about it for a while and reading some stuff, became just patently obvious that this isn't that clear either. There are many exceptions to this, and the rules are kind of fuzzy. If we're in war, I can't murder an opponent. I can kill him, but it's not murder because we're at war. If you try to kill me, but I kill you first to save myself, that's called self-preservation. It's not called murder. So there's a lot of exceptions for things that satisfy these constraints, but that we still would not consider murder. And it's still going to be probably a legal issue as to what happens here. So we're much farther down the path with murder than we are with controlling AI. And what really concerns me about the legal part is the legislatures are going to get focused on some concept, and it's not going to be the one that they really need to be focused on. Because we focused on the snake, we missed the scorpion. I think it's much more likely that the legislatures are going to focus on a snake because they can understand it, they can get their hands around it, but they're missing the scorpion altogether. And I'm hoping that we can, point out that there are snakes and there are scorpions, and we need to deal with both. I do highly recommend this video. It's an hour-long video called The AI Dilemma. It was recorded back in March by Trevor Hasty and another guy, and they talk about some of these concerns with AI, and I thought it was an excellent presentation. If you're interested in this sort of stuff, go look it up on YouTube. It's great. So what are we going to do here, right? How are we going to approach this? I think there are many difficult challenges to make AI trustworthy. Many of them are technical. We need to understand better what these models are really doing and how they work and how they can be controlled and how we may or may not try to influence them in one direction or another. Many technical challenges, absolutely. But I think there's also ethical, philosophical, social, and political problems as well. And so if you're not a technologist, but you have skills in some of these other areas, you can get involved in that way. What are some of the ethical considerations that we should be concerned about? What are the social and political implications that we should look at? How can we control this to get the best from these large language models and very few of the worst? I talked again about the traditional legislatures. I think they're just too slow, and I think they're also too uninformed. There is some representative that has decided to go back and get his PhD in artificial intelligence, I understand. And that's great. Kudos to him for doing that. That means there's only 534 members of the congressional delegation that are largely uninformed by this kind of stuff. That's what really concerns me, is that a lot of the politicians, I'm biased here. I don't think that highly of a lot of politicians. They do what they can. They grab on something they can understand. They focus on the snake. They miss the scorpion altogether. That's very concerning to me. And this whole legislative approach really scares me. I just don't think it's the right approach for what we need to be doing. So what are some better ideas for this? The AI Act makes a distinction on the risk level of an AI. So an AI that's making sentencing decisions or hiring decisions or something like that, those are high-risk decisions. If those AI models are wrong, that is a big problem. There's a lot of ethical and social problems that come from those kind of things. But if the AI that's doing the Netflix recommendation on which movie you're going to watch, That's not such a big thing, right? You know, if it gets it wrong, you're going to watch a stupid movie for a couple of hours. Not a big thing. So let's focus on the high risk cases. And in this case, I think we need to be focusing on the large language models, the ChatGPTs, the BARDs, that kind of stuff. One phrase that I've always liked in this regard is that if we protected our toothbrushes like we protect our diamonds, we would lose a lot fewer toothbrushes. That's true. But we will also lose a lot more diamonds. And it's the loss of the diamonds that I think is the key here. And so let's focus on those things that are high risk that need to have the focus. We'll worry about the other things later. They're just lower risk. Another possible idea, this was kind of suggested in the video, is there's an International Atomic Energy Agency, the IAEA. What if we had an International Artificial Intelligence Agency, the IAIA? That seems to me to be a really interesting proposal. It's a group of people that are technically expert in their field. They can go around to different countries and they can inspect systems and maybe require audits and test for compliance and a lot of different things. But it's not exactly a legislative thing, but it's more than just technical requirements. I think that's a really interesting kind of intermediate ground between these things that might be worth looking at. Some people have said, well, you know, what if somebody does this in the dark, right? They don't tell anybody they're building the next AGI, and what's going to happen there? Well, just kind of like one way to spot people that are growing marijuana in their basement is they're using a ton of energy. To build these large language models takes a ton of computing resources as well. Maybe we just look at the outside from their energy consumption and say, they're using so much energy that they may be building a large language model. Let's go take a look and see what it is they're really doing. So they maybe can't do it completely in isolation, completely in the dark. So coming back to this, 6-month moratorium, I always kind of looked at it as, why don't those guys go do more work on AI, on trustworthy AI? Why don't those guys go do something about the control issues? And it dawned on me that maybe I need to be one of those guys. And I would extend that maybe you need to be one of those people that's looking about how to make AI trustworthy. So how could you help this? You need to understand some more about what's going on, not necessarily the technical parts, but you need to understand what the technology is about and what it can do. And how would you suggest we put some controls in place to minimize the bad use cases? So with that, I just want to thank you for listening to this. I hope you've enjoyed it. I had a lot of fun putting it together. And if you have any comments on it, please contact me in the comments below or send me email at this address here. I would like to continue this discussion. Thank you very much.